line, and the tangent line is important because the tangent line gives us the slope of the tangent line gives us the instantaneous rate of change. That's important. So important that I probably should write this. I'm going to write that the slope of the tangent, in this case, okay, for distance versus time, is the instantaneous rate of change, or velocity. I'll say rate of change, but remember, velocity is rate of change with direction, and we're going in one direction, so velocities, we can say that. So let's take a look at another one of these graphs, and this time, when we look at this graph, it's going to clear up a minute. Okay, I want to look at, let me just see if I can get a little closer, like that. I want to examine, or we're going to take a look and try to figure out how can we find the slope of a tangent line. We know how to find the slope of a secant, right? But not a tangent. We don't have that down yet, right? So we're going to look, let's say, let me move this up a little bit, at time 2, okay? At time 2, let me get black up again. All right, so here's, at time 2, we have a height of 20, right? 2 times 2 is 4, times 5 is 20. So this is 20, and at time 2 we have a height of 20, okay. And let's go from 2 to 3. At 3, we have a height of 45. And we know that we can certainly get this secant line. I'm going to draw the secant line. We'll draw it in green again, but I'm going to make it thinner. Okay, so here's our secant line from 2 to 3, right here. All right, and so if we find the slope of that secant line, well, it's getting close to a tangent, but not quite. Let me move this up a little bit more. I'm trying to get the secant line lined up a little bit better. Oh, I guess it's fine. Okay, so what I want to do is I want to take a look at the distance between our two x values from 2 to 3. Imagine this comes down to 3. It's not. My 3 is a little off. I'll move 3 over. And let's just say the distance between 2 and 3, I'm going to call it h. All right? So I have this distance called h. And it is the distance between my two time values. Right? You with me? So if I'm trying to find the secant line and h gets really, really small, I'm eventually going to approach the tangent line. Do you follow what I'm saying? Okay. So what I want to do is I want to make h get smaller. So instead of going from 2 to 3, I'm going to go from 2 to 2 plus h. So this is, we know this is 3, but let's say it's 2 plus h. Okay? And if I let h get really, really tiny, that line is going to slowly approach a tangent line. Let's take a look at our next curve, and let's let h get smaller here. Okay? So whereas here we're going from 2 to 2 plus h, where 2 plus h equals 3, here we're going to go from 2 to h. Okay, but h is smaller, so this is 2 plus some value h. And of course, h is the distance between 2 and 2 plus h. And we end up with, well, at 2 we know the height is 20. But at 2 plus h, our height's a little less. Let me move that down. Well, I guess that's about right. Okay, and so let's go ahead in green and draw our new secant line between these 2 points. There's a new secant line. It's still a secant, it's not a tangent. Right? But let's let h get even smaller. Over here. So h is going to get smaller. So in black, let's see, we're looking at 2, okay? And h has gotten really small, so to here, actually let me make it straight. And so this is 2 plus h here. And then I have the heights. And look how my tangent line, my secant line, is getting really close to the tangent line. Can you see that? That's what we're trying to do here. Now, what I want to do is, I'm going to change to, and I'm going to call it x. Let's call it 2x. Oh, well, if I do that, then this has to be x plus h, right? So let's figure out what's the slope of this secant line. The slope of this secant line, which would be the velocity average, right? The velocity, I guess, let me move this over just a tiny bit. Based on what we know about velocity average, AVE, isn't that f of, well, let's see, we're on the interval from x to x plus h. That's the interval, right? Not a to b anymore. We're going from x to x plus h. So we have f of x plus h minus f of x. And that's just the f of b minus f of a. Over b minus a, and of course, b is x plus h, over x plus h minus x. This is that's the same formula that we used earlier for the average velocity, right? Well, I can certainly rewrite this as f, I'm going to grab this, let me go ahead and grab the numerator, so to rewrite it. It's f of x plus h minus f of x, and of course, x plus h minus x is just h. So that's the average velocity. This is also known as the difference quotient, okay? So let's give this a name here, okay? Matter of fact, let's box it. This is pretty important. This is something that you need to memorize. And you may have seen this in BC pre-calculus, but this is called the difference quotient. Let me blow this up a little bit. It's easier to write when it's a little bigger. Arrow. Okay, this is called the difference quotient. And the difference quotient is it's the equation for the average rate of change from x to x plus h. I'm going to stop here and we'll continue on the next video.